No, no, not yet. Not right now.
It's a shout out to you.
Okay, hold on. Hold on, though. Hold on. For this thing on the skill set, okay, this problem, the first problem, problem number 1 is always going to be that we're going to use Ohm's law, R is V over I, right? And I'm really, really hoping that we can get that, but, you know, if we can't, you deserve a spanking. And then, what? Resistance.
Oh, that's not what I meant. I meant I, sorry.
I is current. And then 2 is going to be, P is IV, is I squared R, is V squared over R, right? 3 is going to be, and this is all tricky, right? It's going to be that current is delta Q over delta T. 4 is the only difficult one on here, really. Okay, 4 is that power is work over time. Now, power is always going to be one of those guys. IV, I squared R, V squared over R. Okay? Yeah?
Why does the variable for current change from I to delta Q?
Why does the variable Q is charged? The question is, why does the variable for I change from I to delta Q? Are we good? Yeah, they're different things, right? Okay. Now, this formula is not in our data packet, so you just need to know. I don't know why it's not there. Okay, it's a very fundamental relationship in physics. The power is the rate at which you do work. Okay? And then the cute thing I'm going to do, and I think you'll find this is cute, is that work is going to be any manifestation of energy, right? So work is going to be, well, it could be force times distance, 1F mv squared. It could be mgh. In the best of all worlds, we could like speed something up, have a force of friction, have it go uphill. In the case of this one, it's mc delta t, right? So Q, any Q, right? We could melt things, and then it would be ml. Anything that is energy is fair game for what work is. And so you got to be leafing through the data packet. What were those things, right? Okay. But there we have it. And I just did that because IB just loves that. Okay. I've got one of those on the test too. And the test for this unit is like this IB mock exam. So I picked things off of old IB tests, right? And then number 5 is P equals IV equals I squared R equals V squared over R, only it's AC. And so if I give you peak, do we use peak for power? If I give you peak, don't use peak, right? Okay. So these things are RMS, and so you need to use the idea that IRMS or VRMS is equal to I peak or V peak divided by the square root of 2, right? It's that whole concept. So I'm going to try to get you, I'm either going to say, I'm going to give you stuff and I'm going to say what is the peak voltage, right? And you'll have to make a little transformation. Or I'll give you, in the case of this one, a peak voltage, which thou shalt not use. Thou shalt calculate the RMS first and then use the power equation, right? Just remember that to get the real power on this one, you've got to use the RMS. Yeah? That's the one I do for that one. Yeah, that's the one I do. But it has to be VRMS, not V peak that I give you.
Did I put the peak in?
Yeah, don't use peak. You'll get.
Answer by 2 and I got the.
Yeah, there you go. Right. So you've happened upon the notion that the peak power is twice the average power. Remember that a little bit, right? Which invokes the physics theorem that you can, at any point you need to divide or multiply by 2 to get the correct answer. And when you do that, all you need to say is, and multiplying by 2 gives, or dividing by 2 gives, and don't even justify it. Just,
No justification required.
yeah.